Hello, good evening, friends. I'm back with my new video on Chemistry Monday. Today we will discuss about next process of preparation of haloarene by direct halogenation, in which direct halogens are attacking on the benzene species and two products are forming. One is para product and second one is ortho product. Okay, it is taking place in the presence of anhydrous FeCl3 in the dark and cold condition is there. So it is chlorobenzene in the presence of Cl2. Two products are forming, para and ortho. Para will be the major product and ortho will be the matter product. 1,4-dichlorobenzene, 1, 2, 3 and 4, and 1,2-dichlorobenzene, 1, 2, 1,2-dichlorobenzene is there. So this is the preparation of haloarene. Second one is the properties, physical properties of haloalkanes and haloarenes. It is very important. They are colorless and in pure state, and however bromides and iodides develop color on exposure to light because they decompose, they break down. Okay, you can see Ri, they decompose like this. The reaction also happen to Br gives Rr plus Br2. Okay, this is the decomposition of halogen in the presence of light. Next, the property is boiling point and melting point. You have to remember one thing: boiling point will be directly proportional to the molar mass, and boiling point will be inversely proportional to the branching. Where molar mass is more, boiling point is also more. Where branching is there, boiling point will be less. You can see the example, this one and this one. More boiling point is this because it is a straight chain. Second, this one because one branching is there, and third one is this because three branchings are there. So A, B and C. Clear, student? Molecular mass and branching. So two things you have to remember about it, because the order given here of boiling point, number one is Ri, because as we move down the group the size increases, and as the size increases, molar mass also increases. So Ri has the highest boiling point, then Br, then Cl, and then Rf. That is the important factor. Talking about the melting point depend on the symmetry. The highest melting point is of para, and the symmetry of boiling point order is ortho, para and then meta. Clear? Next part is of solubility. They are immiscible, they are insoluble. Why? Because you can see, I can explain with the example here. This is the water molecule, and okay, this will also one water molecule. This will form a hydrogen bond. What will form? It will form a hydrogen bond. Because oxygen is electronegative, so it attracts electron and form hydrogen bond. It is very strong bond. The intermolecular forces are strong. Now alkane will try to break this bond, but it cannot be possible because it is strong bond. Intermolecular forces are high, so more energy is required, so it cannot be soluble in water. You can see here they are immiscible in water. Okay, because large energy is required to break the bond, and that's why they are insoluble or immiscible. Next, the question is there: why does p-chlorobenzene, para-dichlorobenzene have higher melting point than the corresponding ortho isomer and meta isomer? So see, in para, the symmetry is like this. So symmetry is responsible for their intermolecular forces, and the forces are strong in para, so their crystalline lattice structure is there, so their high intermolecular forces are there in para, so para is stronger than ortho and meta isomer. Clear, guys? Next one is the chemical properties of haloalkane and haloarene. Nucleophilic substitution reaction, very important reaction. First understand, nucleophilic means nucleus. Nucleo means nucleus, philic means loving. Substitution means replacement. Okay, which it is nucleus loving, so it will be negative part. Negative part will attract the nucleus. Okay, so we will take the example. You can represent the nucleophile like this. We can take the example of Rx plus nucleophile like this. This is positive part and this is negative part. It will come here and try to break the bond. Okay, and it will give like this, R and U plus X minus will be there. Okay, so it will be the product. So X plus is there, X minus is there. Okay, take one more example, Rx plus NaOH. This is the negative part, this is the positive part. This will come and try to break the bond here and remove X halogen and take the position OH plus NX. Okay, next example is Rx plus HOH. This is positive part and this is negative part. This will come here and break the bond. It will make ROH plus RX. Next important example is Rx plus AgCN. You can see silver cyanide. Okay, this positive part and negative part, it will come here, and what it will make in this cyanide is there, but in product what will form? R and C. Isocyanide will be formed. Okay, guys, so this is the byproduct. I hope you like the video, and this is a short video of preparing board exam for prepared board exam. So I hope you like this video. Please subscribe and like my channel. Thank you and have a nice day.